Number 3 shows us the frequency distributions of two data sets. So we're basically looking at two different dot plots. We don't know if we're talking about how many pets you have, how many siblings you have. We don't really know the story here, so we don't have to worry about that too much. We really just want to compare the two. It looks pretty much the same to me, except there's an outlier, right? So remember in that last problem we said that an outlier is a point that lies outside of the rest of the data points, or one that is far away from the rest of the data points. So it's identical except for this one has an outlier. And then what the question is then asking is that how does that change the numbers? Well, the only way for us to do that would just be to throw the numbers in the calculator and then let's do a comparison. So, and what it's asking us to compare, if we notice this little box here, is the mean, median, and standard deviation. So what I'm going to want to do here is I'm going to want to figure out the mean, median, and standard deviation for data set 1, and then I want to figure out the mean, median, and standard deviation for the second data set. All right, we'll separate those two. So this is going to be data set 1. So this is set 1. And then this is going to be for set 2. All right, well, let's just do one at a time. So let's go back to stat, edit, clear out the numbers from the last problem, and let's do data set 1. So it looks like there's, starting on the left here, there's two zeros. So I'd hit 0, enter in twice. So 0, 0. Got a lot of ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 ones. 3, 4, 5, 6, 7, 8, and 9. And we've got 1, 2, 3, 4, 5, 6 twos. And we've got 3 threes. 2 and 3. So it looks like we have a total of 20 data points here. They didn't tell us what our total was. Let me just make sure that's right. Calculator's saying we got a total of 20 numbers. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, good. Got them all in there. Let's go back to stat and calc. And we're going to do one variable statistics. Let's hit enter, and then let's see what the numbers tell us. So the average here is 1.5. And the median, to get the median, you have to scroll down a couple there. So the median is 1. And then the standard deviation is 0.88 or 0.89. Maybe we'll round to 0.89. And then what we're going to do is that we're going to do the same thing, but for the second data set. Now, we don't actually have to retype all the numbers, because remember, the two data sets are the same. The only difference is the second one has an outlier. So all that I need to do is just go to the end of the list. I can scroll down to the end, or a shortcut is that when you're at the top, if you scroll up, it takes you back down to the bottom. So all I need to do is just put a 6 in here for my 21st number, and then now I'm just going to rerun the numbers. And basically what this question is after is asking, how does an outlier affect? If you have an outlier, what does that do to your numbers? So we'll go stat calc, and we'll run the numbers again. So we get 1.7 for our average, or our mean. Our median, scroll down a couple here, is 1. And then our standard deviation is 1.3. What was that? 1.3. We can round to 1 here. And by the way, with this question, all these questions, the rounding, it's really kind of subjective. You know, we just round to a number that makes sense. So don't stress too much about, you know, exactly what you round to. Well, I can spot right away if I look at what's, you know, how's it the same, how's it the different. I can see right away that what looks to be the same is the median. The middle is still the same number here, right? So the median ended up staying the same. So that's equal for both data sets. What changed is that if we look at for the first set, we have an average of 1.5. That's not my highlighter. we have an average of 1.5 versus an average of 1.7. So what it looks like is that for data set 2, that the mean actually increased. And then let's look at the standard deviation. If we compare the standard deviations, 0.89 and 1.31. So the standard deviation for the second one is larger as well. So this would be greater for data set 2. So what does all of that mean? Well, what it means is that if I have some numbers and then I throw another number in there and it's a bigger number, well, wouldn't that make sense that the average would go up, right? Because we threw in a bigger number here. So our average ended up changing. Also, now I've got a number that's further spread out from the group. Remember that standard deviation is a measure of spread. So if I've got a number that's spread out here, the numbers, my first data set are pretty close. For the second data set, I've got a number that's way out there. So I would expect that the standard deviation would increase. What didn't change? What didn't change is the median, which is the middle number. So what ends up happening is that the median is a lot less susceptible to being influenced by an outlier. So oftentimes you'll hear quotes on the news or in an article, they talk about the median home price or the median salary for a particular job. We use median because, again, it is less susceptible to an outlier. So what we could say here is that the median stayed the same, the middle number, right? That's what we mean by median. The median stays the same, but the outlier increased the mean, which is our average, the mean, and the standard deviation. And the standard deviation, right? Because if I had a list of numbers, and I just want to finish with this thought on this problem, is that if I had a list of numbers, and this has nothing to do with this particular problem, so you don't have to write these numbers down. But let's say I had a list of numbers. Let's say I had 1, 5, 7, 10, and let's throw another one on there. Let's say 13. If I wanted to know what the middle, right, because that's what the median is. If I wanted to know what the middle is of these numbers, well, let's see, what's the middle number? 7 is the middle number. Now, if I change that 13, let's say I change that 13, let's say I change that number to 30, right? Like I made the number a lot larger. Did that change what number's the middle? No. So it didn't change what the middle was. So you can throw another number on there. Throwing in 30, a bigger number, will definitely change the average, like what we saw with this problem, but it doesn't change the middle, right? So it's more of a stable measure when we're talking about outliers. All right, so let's go ahead and stop here and try number 3 on the right side.